So again, this is just an extension of what we did yesterday. It's going to get just slightly more complicated. The numbers we're going to be dealing with are more complicated. So for example, if I say to you, complete the square of this, we have y equals 4x squared plus 10x. We nudge that constant term over, and then we have to factor the coefficient of x squared out of both x terms. And this is where things take a little bit of a turn compared to yesterday. When I factor that 4 out of x squared, I get 4x squared, not a problem. When I factor the 4 out of 10x, the problem is 4 doesn't divide into 10x without remainder. It's not like we're taking 4 out of 12x or 4 out of 20x. We're taking it out of 10x. But if I asked you to factor 4x squared minus 12x, and you took a 4 out of that, because we're just worried about taking the number out, not the x. I think most of you just look at it and say it's x squared minus 3x. Am I right? How many of you do what I do? And I thought everybody did this, and then I realized I'm in a very small part of the population. How many of you say this is a 3 because 3 times 4 is 12? How many of you say it's 3 because you take 12 divided by 4? Most people do that. I thought it was just, well, the number that you multiply by 4 is to get 12 is 3, so it must be 3. But most people divide. My point is when you do factoring, you're dividing. So what I have left here is going to be 10 over 4 times x. I'm dividing by 4. But we wrote that down. We're going to write down another line before we do anything else, because 10 over 4 can be simplified. It's 5 over 2. And now we're ready to add our mystical number that makes this a perfect square. I certainly believe, everyone, that you could very easily go directly to this line without writing out the middle line. 10 divided by 4 is 5 halves. Okay. So now what we need to do is divide 5 halves by 2 and square it. And you need to know how to do this without a calculator. Okay. So yes, if you're in a rush and you just want to know what it is, you can use a calculator. But we want to work in fractions and we want exact values. So I need to take half of 5 over 2. And you'll notice that what I'm saying is half of 5 over 2. I'm not saying 5 over 2 divided by 2. They mean the same thing. But as soon as my brain says 5 over 2 divided by 2, that's weird. It's weird to think about. Or worse yet, 5 over 2 over 2. That's even worse. When you divide something by 2, you're taking half of it. Okay? And by writing it this way, you can very clearly see that half of 5 halves is 5 quarters. As you multiply 5 times 1 across the top, 2 times 2 across the bottom, it's 5 quarters. And just as a shortcut here, I'll tell you right now that anytime you divide a fraction by 2, you double the bottom. If I said to you, what is 5/6 divided by 2? It's 5/12. Because divided by 2 is 1/2 times it. So the bottom is going to double. And what that means, going back to our question, is we have to take this and square it and get 25/16. So 25/16 is the number that we are adding. What are we going to adjust over here? Well, you're going to have to take that 4 and that 25/16 and multiply them. But leading up to a very important unit in this course, when we have 4 times 25 over 16, This isn't the first time I've mentioned this. You see where I wrote that 4? It's up top, right? I didn't do this. Don't get in the habit of doing this. This is going to be your downfall later if you do. It's going to be horrible later. It's 4, which is 4 over 1. And one of the things I'm going to stress in the unit, a few units down the road, is that when you're multiplying, you might as well just have one fraction. Okay? One thing I have stressed again and again, I'll ask, does anybody remember? When are you allowed to cancel something? Jay hesitantly raises his hand. So you have the same number on the top and the bottom. Can I ask you a question, though? Can I cancel the 4 with the 16? No. So there's something else involved here. A little louder, I can't hear you. Right, if it's something being multiplied, and that means, everybody, that it's a factor. So when we take a look at factors, there's a factor of 4 on the top, there's a factor of 4 on the bottom. This is exactly why we can cancel. Whoops. There's a factor of 4 on the bottom. 16 is 4 times 4. This is why we can cancel a 4 out of the top and the bottom. So what we're left with is 25 quarters. And that means we have to subtract, way up here, we have to subtract 25 quarters. Let's work out what that is. 5 is 5 over 1 minus 25 over 4. I can't subtract things unless their denominators are the same, so I'm going to multiply top and bottom by 4 and get 20 over 4 minus 25 over 4, which gives me negative 5 over 4. And I'm telling you, could you have just done all of that number work on your calculator? Of course you could have. Will you always be able to do this kind of work on your calculator? No, you won't. So at every opportunity, if I can explain how to work with the fractions, I will. Now we're going to write this in completed square form. We have a 4. When we were talking extensively a little while ago about what you put in the brackets, I kept trying to push you back to the point that it will be x, and then it will be half of b. B is B is positive 5 over 2. Half of that is 5 over 4. And then we have our minus, well, that's a coincidence. This is minus 5 over 4 as well. So we are asked to do a little sketch. You know me with sketches. I'm not that big of a fan of them in terms of this stuff in the lesson, but you should understand that A is 4 here. P is negative 5 over 4 because it's x minus P, quantity squared. Q happens to be negative 5 over 4 because you can see it's negative 5 over 4. So the vertex of this parabola is at negative 5 over 4, comma, negative 5 over 4. It opens upward, and it is quite narrow because of that 4. So again, if this is x squared, the function we're looking at is quite a bit more narrow, maybe even narrower than that, okay? Let's try another one. What were we asked to do? Rough sketch showing all properties. Well, I guess I'm not showing all properties. You know, I could, where am I? I could draw in the axis of symmetry. I could label the vertex, but I think you get the point. Let's try another one. X squared minus 7x plus 15. Well, this is actually kind of nice because the coefficient of x squared here is already 1. So we don't need to factor anything out. We can just worry right now about adding the number to make this a perfect square trinomial. How do we do that? We take b, divide it by 2, and square it. I would like everybody without a calculator to figure out what we would write when we take negative 7 and we divide it by 2 and square it. It's 49 quarters. Because half of negative 7 squared, well, half of negative 7 is negative 7 over 2. Squared, well, I square negative 7, I square 2, I get 49 over 4. And that means I subtract 49 over 4. I don't need to multiply out anything because I didn't factor anything out. What's out there is a 1. And we're pretty much done. This will be y equals x minus some number, quantity squared. And I need to figure out what 15 minus 49 quarters is. If I multiply top and bottom of 15 by 4 to turn it into quarters, I get 60 quarters minus 49 quarters, I think is 11 quarters. How's my arithmetic? It's okay. And what number do we put in here? You put the number that you had before you squared it. You put half of b, negative 7 over 2. And we're done. P is 7 over 2. Q is 11 over 4. Just going to put in brackets what these are in decimal form, and you can double check on your calculator if you need to. Yes? Okay. A is 1, which means this graph is going to open upwards and have the same shape as x squared, and it will have its vertex at 3.5, comma 2.75. There's nothing wrong with writing decimals instead of fractions if the decimals are nice decimals. And I think you guys get what I mean by nice decimals, right? Not these crazy decimals that go on forever. So not only are you expected to be able to complete the square for simple things, you're expected to be able to complete the square for fractions as well, on paper. All right, number 3. I just need to grab something while I'm talking. Number 3 is the kind of question that you were actually given. It might even be the same as a question you were given in a previous unit. And in the previous unit, you would have solved this problem by using your graphing calculator. Let's do that. While I'm just grabbing something here, can you do me a favor, please, and enter that function into your graphing calculator and do your level best to find some window settings that allow you to see it. So in my mind, as I make my way back to the board, I notice that the y-intercept is 28, which means that it starts 28 meters above the ground. If you have something that is launched into the air, presumably it goes higher than 28. So I would probably go to my table and look at the height for different values of time, starting at 0 seconds. All right, sorry about that. Let me catch up to you here. Negative 5x squared plus 62x plus 28 You know, as I said, knowing the h-intercept is 28, the y-intercept, is valuable. Because what you really know is that it starts off at 28. And I mean, I know I've got it up here, but it starts off at 28 and it's going up, right? So when I take a look at my window settings, I would probably go to my table, setup, start at 0 and go up by 1. And I can see it, you know, after 1 second it's at 85 and it continues to climb, and now it's falling. So I'm looking at the Y part of the table here and seeing that it hits 220 at least, and it starts falling again, and let's keep going. It reaches the ground someplace around 12.5 seconds, or between 12 and 13 seconds. So putting that together, I'm thinking I'm going to go from 0 to 13 seconds, and for height, I'm going to go from 0 to, I can't believe I just forgot that number. Did it reach 220?
Yeah.
Was it 220? I'm going to go to 280, which I'm sure is sufficient. And that's what I'm looking at, okay? Now, I don't have the exact window settings here as I do there, but I want you to pay attention to something. The point of this is that vertex corresponds to a maximum height, right? We're not going to find it on the calculator. I'm just reminding you that we could. And this is the time when the maximum height is reached. So how do we do this problem algebraically? What we do to find that vertex is complete the square. That's all. And if you're good at completing the square, this should take you less time than doing it on your graphing calculator. Bump that 28 down the road. We'll deal with it later. Take the -5 out of this. Now, given that, listen very carefully, given that -5 when you divide it into things gives you nice decimals, when you divide 5 into anything, you're going to get something that ends in no decimals or 0.5, or it'll be nice results, 0.1s maybe. Given that, and the fact that this is a question where we want a decimal answer anyway, you don't need to work with fractions. Take -62 divided by, or take 62 rather, divided by -5. And you should get -12.4. Thank you. So you get -12.4 t. We're going to add a number in here. What number are we going to add? Well, I've already given you permission in this question to work in decimals. So take -12.4 on your calculator, divide by 2 to get 6.2, and then -6.2, and then square it. And you get 38.44, which, you know, let's be honest, if this were a written response question and you wanted fractions, just go math, enter, enter. Who cares? Now I need to multiply these two together. (192.2) negative 192.2. Which means I have to add 192.2. I just have a question for you. How many of you recognize that this is going to be the maximum height? That's going to be your value of Q for the vertex. We'll put this together. The height is -5. Times t minus 6.2 squared, plus, what do we got here, 220.2? Okay, yes, plus 220.2. So the vertex of this is at 6.2, comma, 220.2. So, does the question ask, what is the maximum height?
How long did maximum height at how long?
So, what is the maximum height? 220.2 meters. How long does it take to reach the maximum height? 6.2 seconds. And since it will only take a second, we already have this up here. Just to convince you, if you go to the max in your calculate menu, left, right, enter, 6.2, 220.2. So what we did here, we did without the hassle of window settings. Let's try one more. Two more actually, but we'll move on to the next one. At the last concert in a particular arena, 7,200 seats were sold, and they were sold for 45 clams apiece. Research indicates that for every $4 increase in ticket price, you lose 20 customers. I hope you recognize this is the water bottle problem. It's just not water bottles, it's tickets. Find the optimal price for a ticket in order to maximize the revenue. That means, what should we charge to get the most money? And then it has some other questions as well. So revenue is number of tickets sold multiplied by the amount per ticket. Just like in the question we did with the water bottles, the revenue was the number of water bottles times the cost per water bottle. So what are we going to do here? We have to introduce a variable. I'm curious, does anybody know what we should call x here? Based on what we did with the water bottle question, Ashira? The number of $4 bumps in the price. And I hope you understand that the word bump here means increase. So if we find out x is 3, then that means you need to raise the price by $12, because 3 times 4 is 12. So if we start with the number, or with the price per ticket, they were 45 bucks, and we're going to add, I have a feeling, if I remember right, we're going to get an answer here which is maybe unreasonable. Okay? But I'll talk about that in a bit. Plus 4x. We're adding 4x because 45 is dollars, and x is not dollars. You've got to multiply x by 4 to get dollars. And the number of tickets sold is 7,200, but it's going to drop. And how much is it going to drop by? How many people are we going to lose? Do you know? 20x, good. Because for each x, we lose 20 people. So we're going to do this algebraically. We need to multiply that out first of all. R equals 7,200 times 45, 324,000. That's my first. My outer is 7,200 by 4x. Can you confirm that that's 28,800x? Thank you. My inner is negative 20x times 45. Can you confirm that's negative 900x? And my last is negative 80x squared. Well, now we're going to clean that up and put it into a proper form for a standard form, which is to put my quadratic term first. Then put my x terms. So I need to take 28,800, and before we go on, I want to confirm it is 28,800x, and it is 900x. Okay. We need to subtract 28,800x minus 900x, which is 27,900x. And we're going to have the plus 324,000 over here because we need to add something. Well, I guess we're not going to add yet. What else do we have to do? Factor out that negative 80. Listen, the idea of what we're doing here is the same. The numbers are just bigger, that's all. I need to factor a negative out of a positive. I'm worried that that's not going to divide in evenly, but we're going to find out. It's okay. We'll work in decimals. 348.75. X plus we need to add a number, and then we have that 324,000. I really ought to change this example because, believe me, when we take half of that number and then square it, we're going to have a boatload of decimals. But it's going to turn out it doesn't really matter. I need to take this number, it's actually negative of this. I need to divide it by 2 and then square the result. This is the number I need to add inside of the brackets. 30406 point something. I didn't write down all the decimals, we don't need to. We need to use all the decimals when we multiply these two numbers, though. So I need to take that number and multiply by negative 80, and I get that number. I get, there we go, negative 2432531.25, which means I have to add 2432531.25. I'm going to ask a question. If you don't know the answer, that's fine. I'm just curious. I'm judging the level of understanding right now. Can somebody tell me what the significance of that sum is going to be? I'm not asking what the sum is. What is it? It's going to be the maximum revenue. That number is always going to be the maximum or the minimum of the thing you're trying to find. Cleaning this up, I can write negative 80, which the fact that a is negative 80 has nothing to do with solving the problem. It just tells us the parabola is upside down, which has a maximum. X minus something squared plus whatever this sum is. I have to take that number and add the 324,000, and I get that. 275, 756,531. 756,531.25. What number goes here? Well, I have to take half of the number in front of x. And this is where the reasonableness of this answer goes out the window, but I'm going to justify the wildly inflated ticket price for you in a second. Okay? I need to take 348.75 divided by 2. and get 174.375. 174.375. Okay? So, this is a parabola that opens down with its vertex at 174.375, comma, 2,756,531.25 for a y coordinate. Okay? So let's break this down. What is the maximum revenue? It's this number. This is not the ticket price. What is this? 174.375. Aoki? It's not how many tickets are sold. No, Paige? How many $4 bumps, right? X is, if we go back to the beginning and this is X, X is the number of $4 bumps. So, correct me if I'm wrong, was it $45 a pop? That means the ticket price will be equal to 45 plus 4 times 174.375. All right? This is the optimal ticket price. In order for them to make as much money as possible, they need to sell tickets for $742 and 50 cents. So when I said I really should change this, and I plan on it, I think that's a little wildly inflated. Could we come up with a scenario under which this would be true? Yeah, you know what? They've just discovered that John Lennon is still alive, and George Harrison is still alive, and the Beatles for one night only are going to be playing in this arena. There was this band a long time ago called the Beatles, and 2 of them are currently deceased. John Lennon, who was murdered in 1980 or 79, and George Harrison, who died about 10, 15 years ago. Anyway, we discover it's all a hoax. It's a big conspiracy. They're still alive. And Elvis is going to open for them. So would you have people who would be willing to pay $742.50 a pop? Definitely. Does the question also say how many tickets are sold?
Yep.
Okay. Well, don't forget, if we go all the way back to the top, the number of tickets sold was 7,200 minus 20x. So if we take 7,200 minus 20 times that 148.75, is it 148.75? Oh, it's right there, 375. No. I better look. What did we get? 174.375. Okay. They would only sell out about half the seats, about 3,712. You know, we're going to either say 3,712 and 3,713. You can't have half of a seat. Have half of a person watching the concert. Okay. All right, let's move on. Let's do one more question. This is another area question that's a little bit different than the ones we've looked at. A farmer has, I don't know why, poodles and pit bulls, using the side of the barn for one side of a pen and 600 feet of chicken wire. He wants to create a pen. So what this looks like is you've got a barn here. This is the barn. And he's going to build a pen using the chicken wire but he wants to have a line running down the middle of chicken wire to separate the pit bulls from the poodles. How should he do this to get the most area? What's the maximum area? We have to introduce a variable of x. And in my mind, I would put x as being that distance, this whole distance here. And you can call this L. But I want you to notice that this is L and this is L. Just read the question carefully. Don't shout out an answer, but think carefully about what x plus 3L has to give you. Put your hand up and then down if you know what x plus 3L needs to give you. You know, if he wants the most area. What is it, Craig?
The 600.
The 600. Presumably, if you want the most area, you're going to use as much of the building material as possible. I can't remember because we're doing this in two other classes of mine simultaneously right now. But did I introduce the concept of what's called an equation of constraint? I did. Good. This is an equation of constraint. It means that no matter what the farmer decides to design here, that equation is always going to be true. Always. It doesn't matter whether he makes this 40, whether he makes this 40, this 40, this 40, and this 480. Can you just check, does that add up to 1,600? Yeah. Or whether he makes this adds up to 600. Whether he makes this 140, 140, 140, and this 180, and I think that adds up to 600. Okay. So where do we go from here? We develop a formula for the thing we're trying to maximize. Whoop. There we go. Which is area equals length times width. What's the problem with this equation? What is causing us problems with using that equation? Christy?
It's only counting the one length, like the one, so you need...
Oh, that is true, but area equals length times width is still true, right? And what you're saying is, well, we actually have three lengths, but that's not what I'm getting at. That's not the issue moving forward. Before I get to your suggestion, Jay, I'm going to give you guys kind of a hint here. The principle behind this is if there's a maximum area, there's a graph that has area here that looks like that, right? But graphs only have two variables, y and x. So, Jay, you want to tackle what the issue is here?
We're missing two parabolas. Like we can't solve it yet.
Did you say we're missing two parabolas?
Yeah.
I don't quite, can you expand on that?
Am I saying it wrong? The parameters. Oh my god.
Parameters. Oh, I thought you said parabolas.
You did.
Yeah.
I did say that.
And I'm going to tweak what you said a little bit to parameters, and I'm going to tweak it and say variables. Because all of these letters up here are variables. They're all variables. There's no parameters on the board except for the number 3 and the number 600. Everything else is in flux and can change. And the bottom line is we only want two variables. So this needs to go. We want to be looking at this, area as a function of x. Then we can start talking about maximum. So how do we get rid of Let me give you a hint. There's the hint. How do we get rid of L? No? Christy?
Divide it like with the other side.
Pardon me?
I'm looking back at the last one that we did, but I don't know if it's.
Well, you have it in general. I think what you're looking for is a more specific answer. But in general, what Christy's referring to is we use this equation and we rearrange it for the variable we want to get rid of. So we're going to rearrange for L. We're going to rearrange this top equation of constraint for L. So 3L would be equal to 600 minus X. I can divide everything by 3 and get 200 minus 1/3 X. Just eyeball that and let it stew around in your brain for a minute and make sure you understand how I'm going from X plus 3L equals 600 to L equals 200 minus X over 3. This is going to go in where there's an L. This L is about to become this whole thing. I'll let you in on a secret here. In retrospect, I think it would have been smarter, had I known this is where we were going to land, to call this X and that L. Because then we wouldn't have fractions, but that's okay. What we're going to get is A equals L, which is this beast, 200 minus 1/3 X times X. And we're almost home. Expand this out to get negative 1/3 X squared plus 200X. Aaliyah, do you remember the question you had asked about before where it was plus 0? There was no constant term. That's just like this. It doesn't matter whether there's a constant term or not. Let's complete the square. Ooh, tricky. Take out negative 1/3, which will leave us a negative number. How many x's are we going to have when I factor out 1/3? How much? 600 is right. Because 1/3 times 600 would give you 200. Now we look at what we add. So you have to take half of 600 and square it. I really want to say 22500. No. Don't even try to figure out where I got such a number from. Half of 600 is 300. 300 squared is 90,000. What do I do here? I multiply these two numbers together. I think. That means I have to add 30,000 here. I am asking the same question for a different problem for the third time today. How many of you see that this 30,000 is the maximum area? That number is always going to be Q. Writing this out, area equals negative 1/3 x minus 30 squared. Nate, where am I getting minus 30 from? You know this. Going from here to here. Why am I writing minus 30?
Wouldn't it be negative 300?
Oh, it is negative 300. In other words, Mr. Way, you're wrong. Yeah. Minus 300. So you know where I'm getting negative 300 from. That explains why you didn't know where I was getting negative 30 from. Because you don't have access to this thing in my head. Plus 30,000. All right. What this means is this parabola maxes out when x is 300 and the area is 30,000. And now you can answer the question. If x is 300 and we have 600 feet of fencing, this must be 100 here, 100 here, 100 here. By the way, if you take the length times the width, what do you get? Shouldn't be a big surprise. 30,000, the maximum area. You know, I don't want to say for sure, but you can expect for a written response on the exam next week an applied max-min problem. Whether it's a revenue problem or an area problem or maybe something else. But so far, the only two that you're expected to know how to come up with the equation on your own are these two examples we did today, area and revenue. Some practice problems in your textbook, 7, 8. I don't think you need to do every single one here. Some of these you might have already done already. Algebraically, though, by completing the square. Some more complicated ones with fractions in them, and then some application problems. Some of these application problems, like 14 and 15, you're given the equation. You just have to complete the square. Others, you have to make the equation.